Hello, this is Tomer Hagai with Tintri. We know how important it is to identify the so-called noisy neighbors in our cloud. But what about cases of noisy neighborhoods? Let's take a look at the following use case. Troubleshooting often starts with issues reported by an end user. In our use case, poor VM performance was reported by an application owner. Let's see how we solve it. From the Tintri VM store dashboard, we search for this user's VM, named ttvm-sequel1. Immediately, we can see the latency breakdown between host, network, and storage, specifically for this VM. We can open the VM's graph and get real-time information just by double-clicking the VM. At this point, it would have been very easy to identify host latency and notify the end user about it, but we chose to go with a more advanced example, one that would normally be very complex to troubleshoot. In the graph, we can see that the VM uses low IOPS, but suffers from high network latency of about 15 milliseconds. Moving back to the array level stats, we can see that the overall throughput is pretty low, at an average of around 90 megabytes per second, with an earlier spike of around 300. This means that this array's connectivity should have enough room to accommodate our user's VM I/O. While the information at the VM store level is very robust, in a large cloud environment, a single VM store includes only a piece of the overall information. Therefore, we move to Tintri Global Center that shows us the complete picture. The Tintri Global Center manages 8 VM stores in our environment, and we can see that the aggregate IOPS and throughput is much higher across all of them. Clicking one of the dashboard values brings us back to the graphs, which include a full month of historical data. Clicking the graphs show the top VM contributors at that point in time. We'll do that for throughput and see that there is a large set of VMs that produce a high throughput for a long while. This could be the source for our network bottleneck. I can click one of them and get more information, including which Tintri VM store hosts this VM. If needed, I can click this VM store's URL and move to the VM store's user interface, but I already have it open here. As we just saw, these VMs on the other VM store use very high throughput. Putting this in the context of our original problem, we can now understand that our user's VM, ttvm-sequel1, experiences high network latency since other VMs on another VM store consume the shared bandwidth. This shouldn't happen in a well-designed network, but these network bottlenecks could appear due to insufficient interswitch bandwidth or uplinks and could be very difficult to identify. We can also make this information visible to end users using self-service portals or custom user interfaces. In this example, I chose to use ChatOps with Slack to query the VM statistics. Here I can just chat with the Tintri Slack bot and type "get_stats" along with the VM name. The bot queries the Tintri infrastructure and brings the information back to my chat window. This is a simple and powerful way to provide visibility to cloud end users. It's pretty clear how important good VM level visibility is, but in many cases, a central management layer is key for successful troubleshooting. Thanks for watching.